Hello everyone, in today's lecture we will see that how we can transform three-dimensional Euclidean metric tensor from Cartesian to spherical polar coordinates. The procedure is very simple and straightforward. Students, its line element is given by ds square, that is equal to dx square plus dy square plus dz square, and we want to change it from Cartesian to spherical polar coordinates. So the old coordinates are x, y and z, and we have represented them by x1, x2 and x3, and the new variables will be, sorry, these are the variables, not coordinates. Okay, x1 dash, that is equal to r, x2 dash, that is equal to theta, and x3 dash, that is equal to phi. Now student, we know the transformation equations are x is equal to r sine theta cos phi, y is equal to r sine theta sine phi, and z is equal to r cos of theta. Now student, from the transformation laws of tensors, we know that g mu nu prime, like this is a metric tensor in new coordinates, that at the end will be in the spherical polar coordinates, that is equal to this one. Okay, if it is in a covariant form, then definitely these values will be in the denominator. Now students, you know that g mu nu prime, that is equal to partial x alpha is divided by partial x prime mu, and partial x beta is divided by partial x prime nu, and g alpha beta. Here alpha and beta are dummy variables, and mu and nu are free. Okay, now students, if we take the value of mu and nu, that is equal to 1, means the values of the free variable free indices will be equal to 1, then we can write it as this one. Okay, now we know that we have to substitute the values of the dummy variables, and here the values of the dummy variables vary from 1, 2 and 3. Okay, now if we obviously when we substitute the values of our dummy variables, then definitely we write it in a sum over form. So first of all, we will put alpha and beta 1, so partial x1 1 and g1 1, and then 1 2 2 1 2 2 1 3 3 1 2 3 3 2 and 3 3. Okay, means we have just substituted the value of our dummy variables here. Now students, you know that the Euclidean metric tensor, in a Euclidean metric tensor, g12, g21, g13 means the off diagonal entries are equal to 1. So all of these terms will vanish, and we are left with this one, like g11 prime, that is equal to partial x by partial r square, because this term appears twice. Okay, in the similar way this one. And by using the transformation equations that we have discussed previously, like x is equal to r sine theta cos phi, y is equal to r sine theta sine phi, and z is equal to r cos theta, then we can write it as this one. And after further simplification, like I have used here trigonometric identity, and the answer will become equal to 1. So g11 prime, that is equal to 1. Now if we take the value of mu and nu equal to 2, then we will get g22 prime, that is equal to this one. And after using the values of dummy variables, and we know that the off diagonal entries are equal to 1, so I have just taken the same value like g11, g22 and g33, because only the diagonal entries are equal to 1. Okay, and if we write the other terms, then definitely they will vanish over here. And if we use the values, like obviously x1, x2 and x3 are the values x, y and z, so after substituting these values we will get this one. And after using the transformation equations, like the partial derivative of x with respect to theta and partial derivative of y with respect to theta, obviously you know that x is equal to r sine of theta and cos of phi. If you take its partial derivative with respect to theta, then obviously the derivative of sine theta is equal to cos theta, and we will get this term. And after simplification, we are left with r square. In the similar way, if we find the value of g33 prime, then that is equal to r square sine square of theta. Now student, in a similar way we can find g12 prime, means the value of mu is equal to 1 and nu is equal to 2, and if we substitute all the values, then we will get this one. And after using the values of the partial derivatives, all the terms will vanish and we get the answer 0. And we know that the metric tensor is symmetric, means the G12 is equal to G21. So due to symmetry, G21 prime, that is also equal to 0. In the similar way, we will get the value of G13 prime, and after further simplification you will see that this value will also equal to 0. So G13 prime is equal to 0, and due to symmetry G31 prime is equal to 0. And students, in a similar way, G23 prime, after simplification this term is equal to 0, and at the end we are left with this one, means G mu nu prime, means this is the value of G11 prime, this is the value of G22 prime, and this is the value of G33 prime. And only the diagonal entries retain, and all the other entries will become equal to 0, that I have shown earlier. So student, this is all about this lecture, where I have explained that how you can transform three-dimensional Euclidean metric tensor from Cartesian to spherical polar coordinates. This is all about this lecture. Thank you so much.